Trigonometric ratios. So in this class we are going to start with trigonometric ratios. We are actually studying trigonometry today, and our focus will be on trigonometric ratios. So what is trigonometry? It is that branch of mathematics that deals with studying the relationship between sides and angles of a triangle, especially a right angle triangle. Because in class 10 we will be dealing with angles, relationship of angles. In class 10 trigonometry we will deal with studying the relationship of sides and angles of a right angle triangle only. Okay, trigonometry is much more beyond that, but we will not studying that in this class because that is beyond the scope of class 10. So this is a right angle triangle, and let us say this angle is theta. Then we have this one as hypotenuse AB, this one as perpendicular, and this one as base. This one also can be taken perpendicular if you look at from this side, and this one as base. But since this is this is theta, we are taking this angle as theta. Then we will assume that this side is perpendicular. Okay, it is important that which angle you take as theta. We take this angle as theta, so the side opposite to the angle is taken as the perpendicular. This is important. So the ratio AC by BC, sorry, AC by AB, AC by AB is perpendicular by hypotenuse. This ratio is a function of, this is a function of theta, this angle. Okay, because this is a function of theta, because it is observed that if theta is constant, this ratio also remains constant, P by H. Suppose theta is 30 degree, then P by H will have a constant value. Okay, even if we increase the sides of this right angle triangle, suppose it becomes like this, if this is also, suppose this angle is also 30 degree. So if both this angle and this angle are equal, then P by H will have the same value. Okay? So that is why it is called that, say, if it is bigger, this triangle is bigger, but theta is equal. Suppose theta is equal, then P by H will have same value. P by H will be constant. Whether it becomes bigger or smaller does not matter. If theta is constant, then pH is also constant. Hence, it is a function of theta. So that function is given a name. It is called sine of theta. P by H is sine of theta, or in short, sine theta. So P by H is sine theta. The value of P by H, P by perpendicular by hypotenuse, for this triangle, if theta is 30 degree, is half. Let us see. So if this is half, then it will be half for this triangle also. Okay? It will be df by de also will be half. If we have a smaller triangle where theta is, suppose xyz, where theta is 30 degree, then it is again half xy. You see, P by H is half. Here P by H is half. This ratio is half for this triangle, and it is same for this triangle and this triangle, because the theta is equal in all the cases. So if theta is constant, value remains same. P by H value remains same. Now when theta changes, suppose from 30 degree theta becomes 45 degree. Now the value of P by H becomes something like this. Okay? If theta is 45, now the value of P by H becomes something like this, root 2 by 2. Now this will be, now it is 45 degree and this is also 45 degree, because theta is changed. We assume that this is 45 degree, so it is also 45 degree, it is also 45 degree. Suppose, then the value of P by H will become something else, root 2 by 2, it changes. So it is root 2 by 2 is equal to again df by de xz by xy. See? So the value of P by H is dependent on the angle. It remains constant when theta is same. It changes when it changes, theta changes, it also changes. It remains constant for the same value of theta, and it changes for different value of theta. So we are changing the value of theta here, so we get different value of P by H. Getting my point? So the size of the triangle is not important. What is important is that if theta is constant, the value of P by H will remain same, constant. When the value of theta is a different value, okay, when we change the value of theta, then this also changes. Like for 30 degree, we say that sine of 30 degree is half. So it is sine of 30 degree is half for all angles where this acute angle is 30 degree, irrespective of the size of the triangle. And sine of 45 degree is also root 2 by 2 for all triangles, irrespective of their size, if the acute angle is 45 degree. Okay, so let me repeat that P by H is a function of theta, because this ratio is dependent on theta. The ratio remains constant as long as theta is constant, and it changes when the value of theta changes. Okay, so sine theta is perpendicular by hypotenuse, and similar to sine theta we have cosine of theta, which is also a function of theta, and this is the ratio of base by hypotenuse. Sine theta was perpendicular by hypotenuse. Cosine of theta is base by hypotenuse, B by H. Or cosine of theta, it is simply written as cos theta is base by hypotenuse. Okay, and similar to sine of theta, P, this ratio is also a function of theta. The ratio remains constant as long as theta is constant. It will change when theta changes, irrespective of the size of the triangle. Okay, and we also have some other ratios like cosecant of theta, tangent of theta, which is perpendicular by base, or simply tan theta, E by B. Then cosecant of theta, which is hypotenuse by perpendicular, or cosec theta. Okay, then we have secant of theta, which is hypotenuse by base, or sec theta, hypotenuse by base, and cotangent of theta is base by perpendicular, or cot theta, base B by P. So all these ratios are functions of theta. And also you will see this one, B by P, sec H by D, sin theta is P by H, this is H by P, so these two are reciprocal. One is cosec theta, it is H by P. Okay, so if you put 1 by cosec theta, you get sin theta, and cosec theta is 1 by sin theta. Similarly, this is 1 by sec theta, H by B, B by H. So 1 by sec theta is cos theta, and sec theta is 1 by cos theta, and tan theta is P by B. This is 1 by cot theta, and this is 1 by tan theta, and tan theta can also be P by H, B by H, sin theta by cos theta, and so on, like this. So we can get the ratios, one ratio from another ratio, like this. So in the next class, we will see practical applications of these trigonometric ratios, like finding the height of a building, or finding the width of a river or a plot of land in survey, in construction, and different practical applications. So this is it for today.